Hello students, a warm welcome to all of you at AriserTalent. So in our previous lecture, we have discussed about some of the competitive exam questions that are important from your chapter number 2 of the chemistry class 10th, that is acid, base and salt. Now we are going to discuss some more questions which are important from your board exam point of view, that is your NCERT questions. So now we will dealing with our first question, that is a solution turns red litmus blue, its pH is likely to be. Now, the solution is turning red to blue. It means it is fixed that the compound will be the base. So, what will happen in this case? The substance is turning red to blue. So, if it is turning red to blue, the compound must be basic, and the basic solution will have a pH range from 7 to 10. This will be the pH range of the basic solutions. So now what will happen in this case? We are provided with the options 1, 4, 5 and 10. So the pH range which is lying between 7 to 14, it must be 7 to 14. So the correct option here will be the option number D. At option number D, that is the pH value of the 10, the substance will change from red litmus to the blue one. Now, we are moving to our next problem. A solution reacts with crushed eggshells to give a gas that turns lime water milky and the solution contains. Now, what happens in this case? We are provided with a crushed eggshells, and we know that the eggshell is basically made of a compound that is known as calcium carbonate. So what will we do in this reaction? Firstly, we have crushed eggshell. This crushed eggshell is basically made up of calcium carbonate. Now, among all these solutions, one of the option is that it will react with CaCO3 and produce a gas which turns lime water milky. So, it is the only one gas that turns lime water milky, and it is carbon dioxide. So, what we will do in this case? We will react CaCO3 with HCl. This is our calcium carbonate. This is hydrochloric acid. This will form calcium hydroxide, plus calcium will react to form calcium hydroxide, and on the other hand we will get here H2O plus CO2. Now you can see in this reaction the byproduct form is carbon dioxide. Now what will happen in this case? This carbon dioxide will turn the lime water milky. So what will happen in this case? CaOH whole twice react with CO2 to form CaCO3. Now this is our lime water. This is carbon dioxide gas. And the product that is obtained in the right hand side of the equation, that is calcium carbonate, it is basically milky in appearance. So, the carbon dioxide gas is turning lime water to milky, and the reaction will take place only in the presence of hydrochloric acid. So, the correct option here will be the option number B. Now, we are moving to our next question. 10 ml of solution of NaOH is found to be neutralized by 8 ml of a given solution. If we take 20 ml of the same solution, the amount of HCl obtained will be. Now, this question can be solved only by the one method, that will be the simpler method called unitary method. So, we are solving our next question. What we have provided with 10 ml of NaOH is neutralizing 8 ml of HCl solution. So 10 ml of NaOH neutralizes 8 ml of HCl. Now we want to find out how much 20 ml of NaOH will neutralize the HCl. So the equation will be here 20 ml of NaOH neutralize. We will apply unitary method over here. 8 here, 10 in the denominator and 20 in the numerator. Now 0 will be cancelled by 0 and 8 into 2 we will get 16 ml. It means 20 ml of NaOH solution will going to neutralize 16 ml. So the correct option here will be option number D. So here option number D will be the correct answer. Now we are moving to our next question. Which one of the following type of the medicines is used for treating indigestion? Now we are considering indigestion as we have already discussed in our chapter number 2 that the indigestions can be basically solved by having the antacids, because antacid contains magnesium hydroxide or some sort of the compounds of the magnesium which will reduce the effect of acidity in the stomach and provide us relief. So what are the medicines used for treating indigestion? It will always be the antacids. Now antibiotic are the substance which are used to reduce the effect of the pain in our body. Analgesics we can use as a painkiller. Antiseptic is used to inhibit the growth of microorganisms in the body. So there is only one option, that is antacid, and antacid is used to neutralize the acidity in the case of the indigestion, or we can say that it is hyperdigestion. Now we are moving to our next problem. Write the word equation and balance the reaction taking place. So we are writing the word equation and the symbol equation of the following compounds. Our first question is dilute sulfuric acid react with zinc granules. So firstly we are provided with dilute sulfuric acid and it is reacting with zinc granules. What we will get in the product side? We will get ZnSO4 with the liberation of hydrogen gas. Now this is our dilute sulfuric acid. This is zinc. This is zinc sulfate. And this will be our hydrogen gas. Now we can see here the H2SO4 will be available in the liquid form. Zinc will be solid. Zinc sulfate will be sometimes solid or sometimes liquid or aqueous, and hydrogen is a gas. So for writing the complete balanced equation, we have to specify all the things here. We have to write the word equation below the equation, that is in the symbol form, and we have to specify the state of the matter, whether it is solid, liquid or gas. Now we are proceeding to our next problem. Dilute hydrochloric acid react with magnesium ribbon. So our second question is dilute hydrochloric acid, that is HCl, and it is going to react with Mg. So what we will get in the product side? We will get magnesium chloride with the evolution of hydrogen gas. Now you can see in this equation, the equation is not balanced because chlorine are 2 and hydrogen are 2. So balancing this equation, I am substituting 2 over here. So this is our hydrochloric acid. This is magnesium ribbon. What we will get in the product side? We are getting magnesium chloride with the evolution of hydrogen gas. Now you can see here the HCl will be present in the liquid form, magnesium is solid, magnesium chloride will be again liquid and hydrogen will be the gas. So this will be the correct way of writing the any balanced chemical equation. Now we are on our third question. Dilute sulfuric acid react with aluminium powder. So our third equation will be dilute sulfuric acid, that is H2SO4. H2SO4 will be liquid or aqueous, react with aluminium powder. Aluminium powder is solid. What we will get in the product side? We will get aluminium sulfate with the evolution of hydrogen gas. This aluminium sulfate will be in salt form, that is it may be solid or liquid form, and this is our sulfuric acid. This is aluminium. This will be aluminium sulfate. And this will be the hydrogen gas. So this will be our complete balanced equation for question number 3. Now we are with our fourth question. Dilute hydrochloric acid react with iron fillings. So our fourth question will be same, that is hydrochloric acid that will be in the liquid form, react with iron fillings. Iron fillings is Fe, that is in the solid form, and what we will get in the product side? We will get FeCl2 with the liberation of hydrogen gas again. So FeCl2 will be in the solid form and this will be in the gaseous form. So this is our hydrochloric acid, this is iron, this is ferrous chloride, and this will be our hydrogen gas. So we can write the balanced equation as follows. So you can copy it from here for the solution of this problem. Now we are moving to our next question. Compounds such as alcohols and glucose also contain hydrogen but are not categorized as an acid. Describe an activity to prove it. So we are considering alcohol and glucose. So firstly, we have to prove this question by the help of an activity. So what we are doing here, we will take a container. Now what will happen in this container? We will take a rubber cork in the bottom of the container and we will fix 2 iron nails here. Now I am connecting these iron nails with a source of a battery, a key or a bulb. Now what will happen in this case? We are connecting this with a source of battery, one bulb here and a key here. Now these are our iron nails and this is a rubber cork. Now we are putting or we are substituting any acid in this container. And these are our iron nails. This will be our rubber cork. And this is our battery. This is bulb and this is key. So this will be the basic elements of the system. Now what we are going to do is, firstly we are taking any of the acid, that will be the sulfuric acid or hydrochloric acid in the container. And as far as you can see here, when the key is pressed on, what will happen in this case? The acid that we have taken in the container will dissociate into ions and start producing electricity or start producing conduction. So what will happen in this case? The bulb will start glowing because the acids have a tendency to dissociate into ions and start conduction. But if we take alcohol and glucose in this case, these are not as much reactive and they are not dissociating into ions. These both will not dissociate into ions. So, if they are not dissociated into ions, the bulb will not going to glow. Bulb will not glow. And if the bulb will not glow, it will not start producing conduction. So, no conduction in case of alcohol and glucose. So, this will be the basic activity that we can done to prove that alcohol and glucose are not able to start conduction in their aqueous solution. So, I hope this activity has been clear to you. So, we can proceed to our next question. Now, our next question is, why does distilled water does not conduct electricity whereas the rainwater does? Now what actually happens in this case? Distilled water is a pure form of water having none of the ions to conduct electricity, but as I am considering the rainwater contain a mixture of salt on it. So if any salt is present, it will start going to conduction. So the distilled water does not conduct electricity because it is the purest form of water without any ions. So we can write here that distilled water it is basically the pure form of water. This pure form of the water does not contain any ions. If there are no ions, there will be no conduction. But what actually happens in the case of the rainwater? Rainwater basically contains iron, so it will start producing conduction. So, for the rainwater we can write so the conduction will be possible in case of the rainwater because it contains some salts and ions. But distilled water is the purest form of the water, so conduction will not be possible in case of the distilled water. Now we are moving to our next question. Why do acids not show acidic behavior in the absence of the water? So what actually happens in the absence of the water? If we are not taking the water, the HCl is not a hydrochloric acid, it is just a hydrogen chloride gas. Now, if we substitute water in it, it will dissociate into ions and start conducting electricity. So, what will happen in case of this? If we are considering HCl without water, it is just a hydrogen chloride gas. It is only hydrogen chloride gas. But if we are considering HCl with the presence of water, this will become hydrochloric acid and start dissociating into ions. So HCl reacting with H2O start giving H plus and Cl minus ions. So we can say that in the presence of water, it may dissociate into ions, and if it dissociate into ions, it will be able to conduct the electricity in the solution. So this will be the correct answer of this question. Now we are moving to our next question. 5 solutions A, B, C, D, E when tested with universal indicator shows the different pH. Which solution is neutral, alkaline, acidic, weakly alkaline? So now we will discuss this problem, and this problem is somewhat like Hott's problem, that is from your NCERT question. So firstly, we will consider the pH of the solution. The pH given here are 4, 1, 11, 7 and 9. So I am writing here pH, that is 4, 1, 11, 7 and 9. Now we have to check whether the solution is of acidic nature or basic nature. So here I am writing the nature. Now if the pH value is 4, we can say that the solution will be acidic in nature, but among all these options we have to choose the weakly acidic or strongly acidic. So the solution will be weakly acidic. If the pH is 1, we can say that the solution will be the strong acidic in nature. So the pH value 1 will be strongly acidic. If the pH value is 11, we can say that the solution is strongly alkaline in nature. So the 11 pH will be strongly alkaline. Now if I am considering the pH to be 7, the 7 content of the pH will be neutral in nature. So we can say that the compound will be neutral in nature. If I am considering the pH value 9, I can say that the solution will be weakly alkaline, because strongly alkaline in the case of the 11. So 9 pH will be weakly alkaline. Is it all right? So this will be our pH chart for the different values. Now we have arranged the data according to the pH value. Now what we have to do? We have to arrange all these compounds in the increasing order of the hydrogen ion concentration. So we have discussed in our chapter that the pH value is inversely proportional to the hydrogen ion concentration. More will be the hydrogen ion concentration, lesser will be the pH value, or we can say that the lesser will be the alkaline value. So the correct order of arranging all these data in the increasing order of their hydrogen ion concentration will be So now we have to write all these compounds in the increasing order of their hydrogen ion concentration. So firstly we will mention the name of the compounds here. The 4th number solution will be A. So I am writing A here. After 1 will be the B number compound. So it is B. 11 will be C, and it will be D, and it will be E. So this will be the order of the compounds. We are given that the pH value is 4, 11, 7, 9 respectively. Now we have to check the hydrogen ion concentration in this case. So the increasing order of the hydrogen ion concentration will be C, D, E, A and B. C is strongly alkaline in nature, so we can say that it will have a least hydrogen ion concentration because it is a base. Now D will be considered as a neutral one. Then we can take E is weakly alkaline, so it have a less hydrogen ion concentration. The maximum hydrogen ion concentration will be present in the case of the B because it is the strongly acidic. So the correct order is C, D, E, A, B. So I hope this question must be clear to you according to the pH scale. Now we are moving to our next question, and our next question is equal length of the magnesium ribbons are taken in the test tubes. Equal length of the magnesium ribbons are taken in the two test tubes A and B. In the test tube A, hydrochloric acid is filled, and in test tube B, we have taken the acetic acid. Now, the concentration and amount of both the acids are same, and what we have to conclude? We have to conclude that in which test tube the fizzing will occur more vigorously. So, what we are provided with? We are provided with two test tubes, A and B. In both the test tubes, what we have taken here? We have taken the magnesium ribbon. Here we have taken magnesium ribbon, and here we also have taken magnesium ribbon. Now, what happens in the first test tube? We have added the hydrochloric acid, that is HCl. And in this case, what we have added? We have added acetic acid, that is CH3COOH. Now, we have to find out in which case the fizzing occurs more vigorously. So, the fizzing will occur more vigorously in the case A because the hydrochloric acid is strong acid as compared to acetic acid. So, we can say that this is a strong acid and this is our weak acid. So, what will happen in this case? The fizzing will occur more vigorously. So, in this case, fizzing occurs vigorously. So, we can say that the fizzing will occur more vigorously in the case of the A. So, you can copy it from here. So, we can proceed to our next question. Now, our next question is, fresh milk has a pH of 6. How do you think the pH will change if it turn into the curd? Explain your answer. Now, we have considered the fresh milk has a pH of 6. Now, when it turns into the curd, what will basically happen and what will happen to its pH? We will discuss it now. We have taken a fresh milk. This fresh milk is having a pH of 6. Now, this milk is changes into the curd. What actually happens here? If the milk is changes into curd, it means the milk basically contains lactic acid. This lactic acid, when turns into the curd in the presence of the some sort of bacteria, that is lactobacillus bacteria. Now, the pH is 6. So, on the formation of the curd, the solution is bit alkaline in nature and its pH will change automatically and its pH will be come out to be as 4. So, on adding the lactic acid, or we can say that on the formation of the curd, the pH value will change automatically. Now, we are on our next question. A milkman adds a very small amount of baking soda to the fresh milk. Why does he shift the pH of the fresh milk to 6 to slightly alkaline? Why does this milk take a long time to set as a curd? Now, our question is, a milkman is adding a pinch of baking soda in the fresh milk. Now, what will happen here? In the fresh milk, he is adding a pinch of baking soda. If the baking soda is added to the milk, its pH changes from 6 to slightly alkaline. So what will be the pH? 6 to alkaline. Now, why does milkman do so? The milkman is doing so to maintain the shelf of the milk, so the milk can be sustained or the milk can be kept fresh for a longer time. So he was adding a pinch of baking soda in the fresh milk. Now, why does the milk take a so long time to set as a curd? Because we know that in the milk acid is present, that is lactic acid. If we add a small amount of curd or the pinch of the baking soda in the solution, the pH range will changing to somewhat the alkaline, and the alkaline solution will take a much time to setting as a curd. So this is the reason why baking soda is added in the fresh milk. Now we are on our next question. Plaster of Paris should be stored in a moisture-proof container. Explain why. Now, plaster of Paris is basically the calcium sulfate dot half H2O. Now, if it comes in the contact with the water, it will easily absorb the water and settles into a hard solid substance that is called gypsum, that is CaSO4.2H2O. Now, what will happen in this case? If we have plaster of Paris, that is CaSO4.half H2O. Now, if it come in contact with the water, that is moisture, it will hardens into the tough mass, that is CaSO4.2H2O. Now, this is our plaster of Paris. This is water, and this formula is of that of the gypsum. So we can easily see that if it is kept in a moisture proof environment, what will happen? It will set into the hard toughened mass. So it will form the hard solid because it will absorb the water from the moisture. So this will be the basic reaction. So the plaster of the Paris should be kept away from the moisture proof environment. Now we are on our next question. What is neutralization reaction? Give two example. This reaction we have discussed so many times in our class. So the neutralization reactions are basically those reactions in which acid react with base to form salt and water. We have many more examples in this category. So we have the solution of this problem here. Neutralization reaction. Neutralization reactions are those reactions in which acid react with base to form salt and water. Now we have to write example for it. Its example will be NaOH plus HCl. What we will get in the product side? We will get NaCl plus H2O. So this will be our salt and water because here we have taken a base, here we have taken a acid. Now we will take in another example. This is our base, this is our acid, and it is going to form salt and water. Now our next example will be Na2SO4, that is sodium sulfate, or we can take the another example of KOH. We can take here KOH. KOH is the potassium hydroxide, which is again base. It will react with HCl and form potassium chloride with the evolution of water. So again, KOH is a base, HCl is an acid, KCl is a salt, and H2O is water. So we can take many more example of bases and acid to form salt and water. So this is actually the neutralization reaction. Now we are proceeding to our next question. Give two important uses of washing soda and baking soda. As I have already told you, the commercial salts are of very much importance, because the one question that is very important from your exam point of view, that what are its common name, chemical formula and the chemical name, and another term will be the uses of the some of the commercial salt. So we are provided with two salts. First one is washing soda. So firstly, we are writing the uses of the washing soda. Washing soda is basically used to prepare soap, paper, pulp, and sometimes it is used in the textile industry. So it is for its first use will be, it is used in manufacturing of soap, paper, pulp, etc. Secondly, washing soda is basically used for the softening of water. So its second application will be in softening of water. Now we are moving to our next commercial salt. Our next commercial salt is baking soda. So baking soda is basically used as an antacid to neutralize the acidity in the stomach, and secondly, baking soda is used to prepare some of the compounds, like first is baking powder, and from that baking powder we can make a variety of the products. So its first application will be to neutralize acidity in stomach. In case of hyperacidity. Now its second application will be in the formation of baking powder. So baking powder is basically the sodium hydrogen carbonate. So these are the basic application of the some of the commercial salts. So these questions are over for today. In our lecture, we have discussed most of the NCERT problems. So this chapter is over for today. We will deal with our next chapter in our next class. Thank you so much and have a nice day.